To apply this to the segmentation problem of vision, we have to think a little bit about what feature space we do this in, all right? And it turns out for an awful lot of what we do in clustering and segmentation, and frankly, just about everything in computer vision, the feature space you use is what matters. So here I'm showing you that single line, with the idea being that we're just grouping along a single intensity space. So if I were to cluster using just this simple intensity space, what would it do to this panda picture? And Professor Grauman in Texas, she's got this thing for pandas. Actually, I think she got these pictures somewhere. Well, so let's see. So here's our panda. If I tell it that there's going to be two centers, okay, then I would get a division that looks like this, right? So you can see that basically the lighter pixels have been turned into one region, and the darker pixels have been turned into another region, all right? Now, if I told it instead there were three clusters, you might get something that looks like this, all right? And here you can see there's the bright, the dark, and the gray, all right? Kind of like the good, the bad, and the ugly. So what you're seeing here right away is one of the problems in doing k-means clustering, we'll talk more about this, is that you have to tell it how many clusters there are. And there are methods for then trying to figure that out beyond that, but fundamental to k-means is you already know the number of clusters. When you do this type of clustering, you can think of this as quantizing the feature space, right? So those of you familiar with vector quantization, if you do it in multidimensional space, the idea is you essentially carve a continuous space up into a set of buckets. So this clustering is a quantization of our feature space.